Hello, everybody. This is Gigi from Quadratic Community College. This is the last video of the four-part series in partial fractions. Okay, so let's get started. Suppose you now are decomposing P of x over Q of x, where Q of x has a repeated irreducible quadratic. Okay, which one of those is it? It's this one right here that has an exponent to it, right? You cannot factor that quadratic inside there, and that also has an exponent on top. And that is what we call the repeated irreducible quadratic. Now, just like any repeated factor, we have to account for all factors. So we have to go from 1 to n in terms of the exponent. And then since the denominator, the factor, is a quadratic, the numerator is going to be linear, okay? So then if the denominator have one of those repeated factor plus a linear factor, then that's how it's going to be broken down. All right, now let's take a look at this particular example. So this is going to be, no linear factor attached to it, just one repeated irreducible quadratic. So then you would have two fractions in this case, right? So it would be linear over x squared plus 4 plus a linear over x squared plus 4 altogether square. And that's how we deal with repeated factors. Now, suppose we go and add the left-hand side here, right? The least common denominator is going to be x squared plus 4 squared. So you need to multiply this by 1, okay? What do we mean by that? We need to multiply that fraction, that first fraction there, by x squared plus 4 over x squared plus 4. That's the 1, so that we can get up to common denominator. All right. Now, if we were to add these two fractions together, then the denominator would be the same. So now we just have to compare the numerators, right? So the numerator on the left-hand side would be x to the third plus x squared. The numerator on the right-hand side, once we multiply ax plus b by that red part, plus the cx plus d, this is what we will have. Now we would go ahead and match the coefficients of all of these polynomial terms. So the first term that we have to compare is x to the third. So the a will have to be 1. Okay, and then x squared would be, let's see, x squared would be this term right here. And so that would have to be 1. Okay, so b is 1. Now, how many x's are there? There's no x's on the left, but on the right, we have 4ax plus c, right? Which factor out to be 4a plus c times x, right? So 4a plus c will have to equal to 0, okay? And then the constant 4b plus d will have to be 0 as well, because there's no constant on the left-hand side. So then you'll have 4b plus d equal to 0, right? Now, when you plug 1 into here for a, okay, now in order for that to be 0, c would have to be negative 4. And then again, if you were to plug 1 in for b, then d would have to be negative 4. So we've gotten we have solved for all the letters that we needed to solve for, right? So the fraction that we had started out with will equal to, remember where the a, b, c, d are, right? So your fractions are going to be split into 1x plus 1 over x squared plus 4, and then we'll factor out both negative here, and you will have minus 4x plus 4 over x squared plus 4 altogether squared. And that is how we decompose a fraction with irreducible quadratics. Okay, so that is it for partial fraction decomposition. Up next is going to be integration using this method here, right? We decompose the fraction so that we can take the integral. All right, that is that.